Hello students and welcome to our PowerPoint on breaking minerals, because the way minerals break can actually tell you quite a lot about that mineral. But before we do that, let's talk about crystal shape. Remember that minerals are made of atoms, and those atoms come in a repeating pattern. And because of that repeating pattern, they can have many different shapes. And here you see just 3 of them. But there are many more. There's isometric, hexagonal, tetragonal, orthorhombic, monoclinic, triclinic, and more than that. I've just chosen these to show you here. However, you don't need to know them, thankfully. All you need to know is that crystal shape is a method of identifying minerals. Certain minerals form certain crystal shapes. For example, quartz crystals, the nice clear crystal points that you normally see, they form hexagonal crystals. Then there's fracture, okay? These are minerals that break with uneven, rough, or jagged edges. So if it breaks like glass into a bazillion little pieces, when you hit it with a hammer, that would be fracture, okay? So that's the mineral olivine. So if you could reach out and grab the mineral and go, ow, I cut myself, ow, ow, ow. That would be fracture, okay? Because it's rough or jagged edges. Or if you break a mineral, you could have cleavage. Cleavage refers to minerals that break on smooth, flat surfaces, almost as if you had cut and polished it, pretty much. And it can be in one or more directions. For example, the mineral in the corner here, this is the mineral mica. It has perfect cleavage in one direction. You can split it into planes that are as smooth as paper using nothing but your hands. Okay? Now this is calcite here. Note how, as it's breaking, it forms these nice, smooth surfaces. And it will always break along the same lines, forming smaller and smaller crystals of the same shape.
We might need a new feature.
Okay? Now the reason why that happens is because of the crystal itself. As I said, crystals are formed from repeating patterns of atoms. And at times, that repeating pattern of atoms creates repeating weak spots. And if they all happen to line up, you hit it on that weak spot and it will split as if you cut it with a knife. Okay, forming a smooth edge. So here we have that calcite crystal, and as you can see, there are gaps in between these groups of atoms. So if I were to smack it here, or along there, or conversely along this line here, it would split cleanly, forming a cleavage plate. Now, important thing to note is cleavage is not crystal shape. They are totally separate things. One is how the crystal forms, the other is how you shatter it into a billion pieces. So for example, this is my favorite mineral I mentioned before, fluorite. Fluorite is beautiful, it's purple, and it forms cubes quite often in its crystal shape. However, if I were to take this beautiful crystal of fluorite that's probably worth a couple $1,000 and smash it with a hammer, it will form these lovely octahedrons, which I think are actually cooler than the cubes that it normally forms. So it forms cubic and then forms octahedrons when you smash it. Rather interesting, don't you think? Then there's the acid test. Because of course, this lab or this PowerPoint is all about torturing minerals. Do you expect me to talk, mineral? No, I expect you to die. And that's what we do with acid. Basically, you dump acid on the mineral, and if it bubbles, then it is the mineral calcite. Basically testing it for calcium carbonate. Doesn't need to be strong acid, just a weak acid will do. There goes the acid. you can see it pretty much fizzes almost immediately. Okay. This is pretty much exactly the same thing. If you've ever done the famous baking soda and vinegar reaction, same thing. Except what the solid is like the baking soda, and the acid is the vinegar is the acid. Okay. Well, that's it for this particular PowerPoint. See you next time for mineral hardness.